Welcome to a lesson with Dr. Powell. Let's take a look at induction for just a minute. Let's suppose that we want to show the following, that the nth derivative of x to the n is always n factorial. How in the world do we do this? Well, the principle of induction is, first we need to establish a chain of events. Let's suppose that this right here is the statement a sub n. So we establish a chain of implication arrows. So to A2, to A3, and so forth forever. And the next thing we do is we show that the first guy is true. So if we know this guy is true and this guy is true, that'll establish the truth of all of the statements. If this is true, then that forces everything above it to also be true in the implications. Well, how do we do that? This is really the meat of the argument. How do we show that? Oftentimes it's hard to construct an argument, to know exactly what to do. So it's helpful just to write out the different statements. So a sub 1, that just means the first derivative is equal to 1 factorial, okay? Let's look at the second derivative and see what's happening here. We take two derivatives. We get x squared, we get 2 to the x. We get 2. Okay, so we go take three derivatives. We have x cubed, 3x squared, 3 times 2 times x. Notice I'm going to write this out. I'm going to be looking for patterns to see how I can use things that came before. See this 2 and this 2 right here, 2 times 1. And if we do x to the fourth, let's just write it out like this. 4x cubed, 4 times 3, x squared, 4 times 3 times 2 times x, and 4 times 3 times 2 times 1. Notice that in here, see this 3 times 2 times 1 that appears here. So you notice the previous step occurring or happening in the next one up. Let's kind of see how we can use how actually this idea is used in the computation of x to the fourth. Now notice when we're taking the derivative of x cubed, that's actually after we've taken one derivative already. So we take one derivative and then we have an x cubed and then we go for it. That actually tells us a lot about what we're actually trying to do. We take, so we start with x to the fourth. We take one derivative, x cubed, 4, but the 4 stays on the outside. And we already know right here that this derivative is 3 factorial. Then we're done. So in general, let's see what we would do. If we have x to the n, what happens? We take one derivative. We get n. We get n times x to the n minus 1. Well, if we're trying to show a sub n implies a sub n plus 1, maybe, and this statement is a statement of the n plus first derivative, maybe we should start with and x to the n plus 1, maybe we should start with x to the n plus 1. Let's write out what a sub n plus 1 is. A sub n plus 1 is a statement that we're trying to show where n is replaced with n plus 1. So this is the statement that the n plus first derivative of x to the n plus 1 is equal to n plus 1 factorial. So can we get that from here? Well, let's see. The derivative of this is, using the same idea that we had, that we just saw, is n plus 1 to the x to the n. Now we're taking oh, look, this is a constant, and now we're taking n derivatives of this. Well, by our hypothesis or our assumption statement, a sub n. So if we assume that, that means we can use it. So see this, we're going to use it to go to the next place. So we can use this, the derivative of this is n factorial. Aha, we use it and look. We get n plus 1 times n factorial is n plus 1 factorial. We have just shown this general implication. Now, after we have this general implication, all we got to do is show the first guy is true, which we actually did when we were just experimenting. So therefore, the proof is done. We've shown that the first thing is true and that the whole chain is established. We have all these implications. Thanks for watching.